Wine tasting is a big enterprise. We have so many different flavors in wine. Now, it's not easy to describe what something tastes like. We have some words like sweet, sour, salty, bitter, but most of the time when we try to describe a new flavor, we do it in terms of something that's more familiar. So many times we say, it tastes like chicken. That's not for wine, of course. I looked in Wikipedia to find a table of different wines and different flavors that people have reported finding in the wines. Okay, now most of these are things like fruits and spices. That makes sense to me because wine is made from fruit. Then we also had wet wool, petrol, tar, pencil shavings, farmyard, and tobacco. Seriously, people, you drink this stuff? Well, whatever. We do something similar in math. When we have a function that's too complicated for us to calculate very easily, we expand it in a series of other functions that are easy to calculate. When we get to quantum chemistry, we have some pretty complicated mathematical functions for the orbitals of electrons in atoms. Okay. We can only solve these equations exactly for the simplest cases. So when we have more complicated ones, we use sums of the simple ones. Now we can do a lot of analysis sometimes without writing out all those equations in detail. So we just give them names like s orbital and p orbital. Now when we go to the Schrödinger's cat experiment, we have no hope of writing out the solution of the Schrödinger's equation for a cat, or even for the Geiger counter and the diabolical device that may kill the cat. Maybe for the atom is decayed and undecayed. Anyway, we just write out the functions, and here's what they look like. Now let's go back to wine tasting for a moment. Wikipedia tells us that Merlot has the flavors of black cherry, plum, and tomato. Let's assume that it's 40% black cherry, 30% plum, and 30% tomato. Now, if we pour 10 different glasses, we expect them to all taste the same. That's the way ordinary experience works. But suppose we had a quantum mechanical Merlot. In that case, the combination of flavors might look something like this. And if we poured 10 different bottles, it would come out that 4 of them tasted like black cherry, 3 of them like plum, and 3 like tomato. If that sounds weird to you, you're not alone. Schrödinger thought it was pretty weird too, and that's why he wrote the paper about the cat. If we do the cat experiment multiple times, then 50% of the time the cat will be alive, 50% of the time it will be dead, and we never know what's going to happen on the next experiment. Now, in classical mechanics, we expect to get a definite answer when we do a calculation. This works fine for large objects. That means it has a large number of atoms. That's you and me, the bottle of wine, the cat, whatever. But on quantum mechanics, we only get probabilities for the individual atoms. Now, why does that happen? I think Richard Feynman summed it up pretty well by saying, nobody understands quantum mechanics. You can find a lot more videos on Schrödinger's cat. In addition, I wrote one on Schrödinger's lottery, which deals mostly with the role of probabilities in quantum mechanics. Thank you for watching.